Hello everyone, this is Khairul Alam Shobus from All Math Matters. Welcome to my online math class. Hello students, so today I am going to take another class, and this is one of the most important class because today I'll try to explain a very complicated chapter in A level, actually for the pure maths and as well as for the further pure maths. So I found that some students are facing problem in this chapter, but I'll try to explain this chapter quite easily, and in my lecture I'll show all the possible formulas and also the all possible rules from complex number. So in my lecture I'll try to cover these following things. So first we will learn what is the complex number, then properties of complex number, number 3 modulus and argument of a complex number, polar form, and we learn a Argand diagram for a complex number, and number 5 we will learn the square roots, number 6 we will learn the cube roots of unity and their characteristics. Finally we will learn two important theorem, one is the Moivre theorem and another is Euler theorem. Okay, first question is, what is complex number? So for learning the complex number, first you need to learn what is imaginary unit and what is imaginary number. Okay, first imaginary unit. Okay, so square root of -1 is called imaginary unit, that is it denoted by I. So I is imaginary unit. Imaginary unit. That means when any number, that is any negative number inside root, then we use this I. Actually in our other topics except complex number, when we do the sum from other topics and if anywhere arise negative something inside root, then we always ignore this, but in this chapter we'll do all the sums about this negative root. Okay, so from here we can find some values of I. So if we square this both sides, it will be I square, which is -1. So this is one of the most important formula for I. So if anywhere of this chapter I square is arised, then you always use I square equal -1. So now we learn some power of I. So what are the different power of I, that is imaginary unit? So if it is I square equal -1, so if it is I cube, then what will be the value of this? So I cube we can write it like that, I multiple I square, that is I multiple -1, ultimately it is -I. So if it is I to the power 4, that means it should be I square multiple I square, that is -1 multiple -1, which is +1. So in that way you can write some general form, that is if the power of I is I to the power 4n, so then you can easily write it 1, where n equal 0, 1, 2 up to n. That means anything, so I to the power anything which is multiple of 4, then you can easily write it 1. So if it is I to the power 4n plus 1, then you can write it just simply I. If it is I to the power 4n plus 2, so you can write it -1. So if it is I to the power 4n plus 3, then you can write it -I. So in that way you can easily find what will be the power of I. So this is so important because in some case this question will come to your exam. Okay, now we will learn what is the imaginary number. Okay, now we will learn imaginary number. Imaginary number. So imaginary number is, so if we multiply this imaginary unit with any real number, so then it will make an imaginary number. So what? So for an example, x multiple I, that is xi, or a multiple I, that is ai, or specifically you can say 3i, 4i. So these are the imaginary number. That means product of any real number and imaginary unit I is called imaginary number. So these are the imaginary number. So here x and a could be any value. That's why in general it is written xi or ai. So now finally we learn what is complex number. So now we learn what is complex number. Okay, so complex number. So what is the complex number? So complex number is, that means if the question asks you to what is the complex number, so complex number is a plus ib. This is a complex number. That means if we add or subtract any imaginary number with a real number, that means then this whole number is called complex number. Again, if we add or subtract any imaginary number with a real number, then this number is called complex number. So it could be, so in general complex number is written with z, that is it is that means it is denoted by z, and we can write it like that, x plus iy. So this is the general form of complex number. So it could be a plus ib, no problem. It could be p plus iq, no problem. Or specifically you can write it 3 plus 4i, or 2 minus 3i, or 5 plus 7i. So look at each and every complex number, there are two parts. One is real part, another is imaginary part. So in complex number there are two parts, one is real, another is imaginary number. So if it is written 2i, so sometimes some students are confused about this imaginary number or complex number. Suppose 2i, what is the number? So it could be an imaginary number or it could be a complex number, but how? So according to my definition, if we add 0 with this number, then it is a complex number. So here the 0 is real part and 2i is the imaginary part. So in conclude, we can say that all imaginary number are complex number, but all complex number are not imaginary number. That means it could be the all imaginary number, you can convert it into the complex number, but all complex number cannot be converted into the imaginary number. So this is about the complex number. So I think now everyone clear about this complex number. So now we will learn some properties of this complex number. Okay. So if we write the general form of this complex number, that is x plus iy. Okay, now we will learn what is conjugate complex number. Conjugate complex number. Okay, so this is so easy. For an example, a complex number is given like z x plus iy. So if the question asks you to write a conjugate complex number, then you can write it like that, z bar, that is x negative iy. That means the opposite of this given complex number is called conjugate complex number. So if it is given like that, x plus x negative iy, so the conjugate of this complex number should be x plus iy. So in this two conjugate numbers we can conclude two things. So number one, sum of two conjugate numbers always a real number, always a real number, always a real number. Number two, product of two conjugate numbers, always a real number. So how? So if you look at this is the two conjugate numbers. So if you add these two numbers, then you can easily eliminate iy and negative iy. Then what will get? 2x. So we know that here 2x is the real number, because if there is no I, that means it is a real number. But if you see that here is a I or square root of negative value, then it is a complex number. Or what is the product of these two conjugate numbers? So if you multiply these two, then you will get a algebraic formula, that is a plus b into a minus b. So if you do this, then you will get x square negative I square y square, or we can write x square plus y square, because here I square is negative 1. So this is also a real value, that is the real number. So you must keep in mind these two things. Okay, now we will learn another things by using these conjugate numbers. Okay, suppose a rational complex number is given, suppose 2 plus 3i and another is 3 minus 4i. If the question asks you to write this expression into the a plus ib form, so then what is the value of a and what is the value of b? How we can solve this? Suppose this expression is given and question asks you to find an expression a plus ib. So how we can do this? Here we need this conjugate complex number. So how? Okay, you always look at the denominator. So here the denominator is 3 negative 4i. So we must multiply the both numerator and denominator with the conjugate numbers of this denominator. That means 3 plus 4i. So in the denominator it should be 3 plus 4i, and 3 negative 4i will remain same. So now if we do the workout here, so look at in the denominator it is also a algebraic formula, a square negative b square, that is you can write it 3 square 4 square I square. In the numerator you just do the normal multiplication, 2 3s are 6, 2 4s are 8i, 3 3s are 9i, and 3 4s are 12i square. So we already know that I square means negative 1. So if you put here negative 1, it should be 9 plus 16, and it should be 6 negative 12, and 8 plus 9 17i. Okay, now we can write here negative 6 plus 17i over 25, or finally we can write 6 over 25 plus I 17 over 25. So now if you look at, this is the value of A and this is the value of B. That means this is the expression of this given complex number. So in that way you can easily express any rational complex number into the A plus IB form. Okay, now we will learn what is the modulus and argument of a complex number. So this is very crucial for your exam. Okay, now what is the modulus and argument? Okay, let's say again z is the complex number which is x plus iy. Okay, so if we consider here x equal r cos theta and y equal r sin theta, and if we do some calculation here, then we will get the modulus and argument. So now what will be the modulus and what will be the argument? Okay, for finding the modulus, first we can square these two equation and add, then we'll get the modulus. So if you do this, x square plus y square, and in the right hand side r square cos square theta plus r square sin square theta. Okay, now if we use this right side, and you can convert, you can exchange this side, so you can write it like that: r square, that is cos square theta plus sin square theta, equal x square plus y square. So we already know that in trigonometry cos square theta plus sin square theta equal 1. So if we write here 1, that is r square equal x square plus y square, because we know that sin square theta plus cos square theta equal 1. So here the r equal plus minus square root of x square plus y square. So modulus, what is the meaning of this modulus? Modulus means that should be absolute value, that means the positive value. So we can write modulus of r equal only the positive, that is x square plus y square. So this is the modulus of given complex number. Okay, now we learn the argument of this complex number. Argument means angle of this complex number. Okay, argument. Okay, so now if we divide this equation with the first equation, then what we'll get? In the left side y over x, in the right side r sin theta over r cos theta. So if we cancel these both, then we'll get sin over cos according to trigonometric properties, that is tan theta, and here y over x. So here theta should be tan inverse y over x. That means argument of the given complex number z equal tan inverse y over x. So this is the argument of a complex number. So in that way you can easily find the modulus and argument of any complex number. Okay, now I'll show an example. What is the modulus and argument of a given complex number? Okay, for an example, a complex number is given, that is root 3 plus I. So if the question asks you to find the modulus and argument, so here modulus z equals, so we know that the formula x square plus y square. So if you consider this complex number with the general complex number, so if you look at here, x means root 3 and y, that is the coefficient of I, that is 1. So if we write this, that then it will be root 3 square plus 1 square, that is 3 plus 1 equal root 4, that means 2. Here 2 is the modulus. Now what is the argument? Okay, so argument z equal tan inverse y over x. So here value of y is 1, so tan inverse 1 over x is root 3, 1 over root 3. So if you use your calculator, then you can find it, the value of this. So in the radian form it should be pi by 6, or if you write it in the degree form, it should be 30 degree. So this is the argument of given complex number. So in that way you can easily find the modulus and argument of a given complex number. So now we learn the polar form of this given complex number. Okay, now I'll show this by using this example, because that will be easy for you. We don't need to do the calculation again. So now polar form. So what is the polar form? So the polar form is r cos theta plus I sin theta. If the given complex number is positive, that is plus, you must use here plus. If here given is minus, then you must use here minus. Okay, now we already know that the modulus, that is modulus z equal, we know that is 2. So we just keep the value of this, that you can find it easily. 2 multiple cos, here the value of theta is pi over 6 plus I sine pi over 6. So this is the polar form of this given complex number. Okay, now we will learn another important thing, that is what is Argand diagram. Okay, now we will draw the diagram of this complex number. Okay, now if we consider two axes, because when you draw the diagram in 2 dimension, then you must draw two axes. So for complex number, this is the horizontal axis, x axis, so x o x prime, and this is also the real axis. For complex number, this is the real axis, and another vertical axis y o y prime, this is the imaginary axis. For complex number, this is the imaginary axis. Okay, now how we can draw this complex number in this diagram? So look at, for drawing this diagram, you first look at what is the angle. So theta was pi over 6 and argument r was 2. Okay, so by using your protractor, you first draw an angle pi by 6 or 30 degree. Suppose this is pi by 6. So along x-axis you just draw this angle, and then by using your scale you can take 2 units, that is, let's say this is r equal to. So this is the point. So if you consider this is p, it should be 2 and pi by 3. So now you can draw a perpendicular line here. So this is the value of x, that is 2. This is the, okay, so this is the Argand diagram of this given complex number. So if any question asks you to draw an Argand diagram, so first you need to find the angle theta, and also you need to find the modulus r. Then you can easily draw any complex number in the Argand diagram. Okay, and this is so important in most of the exam. These are the common question. Okay, now we learn what is the square roots of a complex number. Another important part of these topics. Okay, square roots. Okay, so in short, we can memorize a formula. If we consider a complex number z equal x plus iy, now the short technique of finding the square root, that is square root of z, that means x plus or minus iy. So it depends on the given complex number. If given plus, you must use here plus. If it is given minus, you must use here a minus sign. Okay, the formula is plus minus half root over x square plus y square plus x power half. Here given is plus or minus, so you must use the plus or minus. Plus minus I half square root of square plus y square negative x power half. So this is the formula. So by using this formula, you can easily find the square root of any complex number. So if you use this formula, you can find the square root within 10 seconds. Now I'll show an example how to find the square root of a complex number. I think by using this formula, you can quickly find the square roots of this complex number. If we consider a complex number that is 3 plus 4i, keep in mind if the given sign is plus, so you must use here plus. If the given sign is minus, so you must use here minus. So what will be the square root? So if we compare this, here x is 3 and y is 4. So by using this formula, you can easily find the square root. So half, so here x is 3, so 3 square plus 4 square plus 3 power half plus I, so here given plus, so you must use here plus, so I half, same thing, square root of 3 square plus 4 square negative 3 power half. Okay, now if you do the workout, you can easily find the square root. So in short, 3 square equal 9 plus 4 square equals 16. 9 plus 16 is 25. You do the square root, then it should be 5. So you can write here like that, half 5 plus 3 power half plus I half, here should be 5 minus 3 or half. Okay, now if you do the rest of the calculation, so I can do here, then what will get? Plus minus half, 5 plus 3 equal 8, multiple 8 power half plus I half multiple 2 or half. So if we do the rest of the calculation, it should be 4. So if you do the square root, that should be 2 plus here 1. If you do the square root, that should be 1. So finally the square root of this given complex number is 2 plus I. So here given is plus, that's why it is plus. If it is given minus, here must be used the minus sign. So in that way you can easily find the square root of any complex number by using this formula. I think it will save more times in your exam. Okay, now I'll show the full form of this square roots, how we can find this formula. Now I'll derive this formula, how we got this formula. Okay, so some students will do this sum by using the full form. Okay, suppose the given complex number is z, that is x plus iy. So you need to find the square root of this. So traditional method is, so you just do the square root of this x plus iy equal a plus ib. So here the same things. So if it is given plus, you must use here plus. If it is given minus, you must use here minus. So now we'll do some calculation. So if we do the square both sides, then we will get a plus ib whole square. Now it will be x plus iy equal a square plus 2ab multiple I plus I square b square. Here just I use the algebraic formula a plus b whole square. So now x plus iy equal, so we know that I square equal negative 1, so a square negative b square plus I into 2ab, therefore I square equal negative 1. So now if you look at this equation and if we equivalent the coefficient of this equation, here x equal a square minus b square, y equal 2ab. So you can write here a square negative b square equal x and 2ab equal y. So this is equation 1, this is equation 2. So look at, for finding the square root, here we just need to find the value of a and b. So if you able to find the value of a and b and can put here, then you can easily find the square root of this. So from these two equations, how we can find this value of a and b? So look at here, these two equations are simultaneous equation. So we already know that how to solve the simultaneous equation, but here you can also use a tricks to find the value of a and b. But how? So look at, so I can erase this part, then it will be better to write the rest of the calculation. Okay, now look at, so here given, so here one equation is a square negative b square. So somehow if we can able to find the a square plus b square, then it will be better, it will be easy to find the value of a and b by using the elimination method. So we already know that some formula in algebra, so we can use a square plus b square whole square equal a square minus b square whole square plus 4ab. So here a is a square, b and b square. So here we can write a square plus b square equal a square minus b square, the value of a square minus b square equal x. So you can use x, and we can write here 2ab whole square. So a square plus b square whole square, it should be x square plus y square, or a square plus b square equal to plus minus square root of x square plus y square. So look at here, a square plus b square equal to plus minus square root of x square plus y square. But here the question is it here two values are valid or not? So we know that the value of this part is sum of two square numbers. So we know that the sum of two square numbers cannot be negative. So that's why the value should be only the positive one, that is a square plus b square equals to root over x square plus y square. So this is equation 3 for an example. So now if we do the elimination method for number 3 and number 1, then we can easily find the value of x and y. So now if we add these two equations, that is 1 and 3, then what we'll get? So a square negative b square plus a square plus b square equal x plus root over x square plus y square. So if you cancel this b square, then here we'll get a square, 2a square equal root over x square plus y square plus x. So here a square equal half root over x square plus y square plus x. Okay, now a equal plus minus 1 by, so plus minus square root of square plus y square plus x. So this is the value of a. Now what will be the value of b? So now if we do the subtraction of equation 1 and 3, then easily we'll get the value of b. Okay, so now if we subtract equation 1 from 3, then it should be a square plus b square negative a square plus b square equal root over x square plus y square negative x. So here we can cancel both a square, then 2b square equal root over x square plus y square negative x. Here b square equal half root over x square plus y square negative x. So here b equal plus minus half square root x square plus y square negative x power half. So look at, this is the value of a and this is the value of b. Okay, now if we input this value of two values in equation a plus ib, then easily you can find this short formula. So this is the value of a, this is the value of b, then you can easily find the square root of this given complex number. So this is the traditional method. In that way you can also find the square root of any given complex number. So I think the first one is simple for you, and I think it will be very helpful for saving your times, because your examination will be time constrained. So now we will learn number 6, cube roots of unity. Okay, now what is the meaning of this cube roots of unity? Okay, that means unity means 1, then what is the value of this? Usually when we see this in our others chapter, we just write here 1, this equal 1, but in complex number it cannot be 1. Here must be 3 values of this cube roots. So what are the next 2 values? Now we learn what are the next 2 values and their characteristics. Okay, how we can do this? So let x equal this cube root of unity. Now if you do the cube from both sides, if you do the cube in both sides, then it will be 1. So you can write x cube negative 1 equals 0, or x cube. So here we can use the algebraic formula a cube minus b cube, a minus b, a square plus ab plus b square. I just write the simplest form. Okay, here we can say either x equal 1 or x square plus x plus 1 equals 0. So here we just use this value normally, but what is the value of this? Okay, now using the quadratic equation you can easily find the value of this. So x equal negative 1 plus minus root over b square minus 4ac divided 2a. So how it comes? So can you remember this formula? That is, this is the quadratic equation. So here x equal negative b plus minus root over b square minus 4ac divided 2a. So if we use this formula, then you can easily find this, because if you compare this equation with the given, with the general quadratic equation, here a is 1, b is 1 and c also 1. So then what will be the value of this? Negative 1 plus minus root over 1 minus 4 over 2, or finally x equal negative 1 plus minus root over minus 3 by 2. So here finally we can say there are 3 roots of there are 3 roots here. So we can say cube roots of 1 equal 1 is 1. So if we write this separately, then it will be negative 1 plus root negative 3 by 2, negative 1 negative root negative 3 by 2. So if you look at this, here 2 roots are complex number. How? Because the inside root is negative. So now we will learn the characteristics of these 3 roots. So we can consider this is an omega, here is omega square. So we consider a Greek letter omega for defining these 2 roots. So that means now we can say there are 3 cube roots of unity, that is 1, omega and omega square. So now we'll learn some properties. Number 1, sum of 3 roots equals 0. That means 1 plus omega square 0. So this is one of the most important formula in complex number. So from here you can write 2 things, that is 1 plus omega equal to negative omega square, or 1 plus omega square equal to negative omega. So this formula also used in some case. So this is so important. So this is one characteristics of these 3 roots. So another is product. Okay, so what will be the product of these 3 roots? Actually it comes from here. So if you add these 3 numbers, then you will get 0. Now if we multiply these 3, then you will get 1. That means product of 3 roots actually cubic roots, so that should be multiple omega square equal 1, or in short you can say omega cube equal 1. So this is another important formula, omega cube equal 1. So what will be the power of this omega? So in general you can say omega power thrice n equal 1. That means any value power of omega which is multiple of 3, that should be 1. So if it is omega power 3n plus 1, it must be omega if it is omega power 3n plus 2, it should be omega square. For an example, what is the value of omega power 15? So it should be multiple of 3, 3 5 is 15. That means you can see easily it is 1. But what is omega power 16? So you can see it is omega power 15 plus 1. That means it should be omega by using this power. These are the all characteristics of cube roots of unity. So you must use these characteristics for solving your problems. So finally, I'll show two formulas. Actually, this is not the usual formula, but if someone learned the complex number, you must know about these two formula. Actually, this is not formula, to theorem. So according to two mathematicians, this formula is invented. So first one is de Moivre's formula. Or de Moivre's theorem. So what is the theorem? So suppose this is a complex number, so power n. So what is the polar form of this? Actually, so we already learned the polar form of a normal complex number, but here if should be, if it is power n, then what is the polar form? So we already know that the polar form, that is r cos theta plus I sin theta. Okay. Now what is the polar form of this? So then we can use here r to the power n cos theta plus sin theta power n. Here should be I. Okay, now this is the formula for de Moivre's. Actually, here we use the de Moivre's theorem. How? R to the power n. So the formula is cos n theta plus I sin into n theta. That means the power should be multiply with the angle. So in short, we can say that so de Moivre's formula is cos theta plus I sin theta power, let's say m, then it will be easy for you to understand. That should be cos m theta plus I sin m theta. So this is called the de Moivre's theorem, and you must know this theorem. Okay, so now I'll show an example for this from this theorem. Okay, if the question asks you what is the polar form of this, so let's say 1 plus I to the power 10. So how we can find this? So first you find the polar form of this inside complex number 1 plus I. So here r is root over 2 and theta is pi by 4. So you can solve at your home, then you will get it. So then you can write it in the polar form, that is root 2 cos pi by 4 plus I sin pi by 4. Okay, or 10, or you can write it root 2 power 10. Just separate this base, so cos pi by 4 plus I sin pi by 4 or 10. Okay, now you can use this formula. So that should be 32. So cos 10 multiple pi by 4 plus I sin 10 multiple pi by 4. So in that way you can solve a complicated problem quite easily by using this de Moivre's theorem. Okay, so I think this is so important, you must know about this. Actually, when you go to the undergraduate, then I think you'll need this formula. Okay, now last but not the least theorem is Euler theorem. So in my lecture, the last theorem is Euler theorem. Okay. Euler's theorem. So what is the Euler's theorem? So e power I theta, it should be cos theta plus I sin theta. Actually this is the Euler form, so if here is plus minus, you must use here plus minus. It depends on the given form. So this is another theorem you must know. Actually this is important for your next level, actually in your undergraduate level. So these all about this complex number. So I think these are the all possible formulas and concept about this complex number. So I believe that if you practice all these formulas properly at home and also practice the examples properly, then you can solve any problems from complex number. And this is the first part of my lecture, but in the next part I'll try to solve all the past paper questions from complex number. So please everyone watch this lecture completely and try to understand the all concept about complex number. I think it will be very helpful for you. So class, thank you everyone for watching this lecture.